A warm welcome to all. This is Maulika, Assistant Professor, Department of Physics from St. Joseph's College of Arts and Science for Women, Hosur. In this video, I will discuss a few general properties of the nucleus. The atomic nucleus was discovered by Ernest Rutherford in 1911 from alpha scattering experiment. Rutherford experiment on scattering of alpha particles proved that the mass of the atom and the positive charges concentrated in a very small central core called nucleus. The dimension of nucleus is much smaller than the overall dimension of the atom. The nucleus is surrounded by orbiting electrons. The nucleus consists of the elementary particles, protons and neutrons, which are known as nucleons. For example, the nucleus is represented symbolically by Z, where X represents the chemical element, A is the mass number and Z is the atomic number. For example, in carbon has 6 protons and 6 neutrons. We have 3 classification of nuclei. First one is isotopes. Isotopes are atoms of the same element having the same atomic number but different mass number. Second one is isobars. Isobars are atoms of different elements having the same mass number but different atomic number. Isotones. The final one is isotones. Isotones are atoms of different elements having the same number of neutrons. Okay, the next property is the nuclear size. We have a formula to find out the nuclear size, that is radius of the nucleus. The formula is R is equal to R naught a power 1 by 3, where R naught is the constant of proportionality, is equal to 1.3 Fermi. We can find out the radius for all elements using this formula. For example, the radius of the carbon is 3 fermimeter. The radius of the silver is 6.17 centimeter. For uranium, 8.056 fermimeter. The another property is nuclear charge. We know that nucleus consists of protons and neutrons. Neutrons as a neutral charge, proton as a positive charge, right? So the charge of the nucleus is due to the protons present in it. So each proton has a positive charge equal to 1.6 into 10 to the power minus 19 coulomb. So the nuclear charges where the atomic number into the positive charge, that is Ze. Yes, next property is nuclear density. We can calculate the nuclear density using the nuclear mass by nuclear volume. The value is 1.816 into 10 power plus 17 kilogram meter per cube. Okay, so see here, 10 power 17, it is a very huge value, right? So the high value of the nuclear density, it shows the nuclear matter is in an extremely compressed state. Yes, another property is the binding energy. When the protons and neutrons combine to form a nucleus, the mass that disappears, which is called mass defect. And this mass defect, the disappear mass is converted into an equivalent amount of energy. This energy is called binding energy of the nucleus. Then the image represents the binding energy graph. A graph is plotted with the mass number A of the nucleus along the x-axis and binding energy per nucleon along the y-axis. Sorry, in y-axis, in this image, the y-axis, it shows negative of binding energy per nucleon. But it is not negative, it is only binding energy per nucleon. Okay, yes. Now I will explain the binding energy curve. The binding energy per nucleon increases sharply with the mass number A up to 20. It increases slowly after 20. There exists some recurrence peaks corresponding to those nuclei whose mass numbers are multiplies of 4 and they contain not only equal to but also even number of protons and neutrons. For example, helium, carbon, oxygen and neon. The curve becomes almost flat for the mass number between 40 and 120. Beyond 120, it increases slowly as A means mass number increases. The binding energy per nucleon reaches a maximum of 8.8 million electron volt at the mass number 56, which means iron element. So corresponding to the iron nucleus. Yes. Hence, iron nucleus is the most stable element. The average binding energy per nucleon is about 8.5 million electron volt for nuclei having the mass number ranging between 40 and 120. So, these elements are comparatively more stable but non-radioactive elements. For higher mass number, curves drops slowly. The binding energy curve is about 7.6 million electron volt for uranium. Hence, they are called unstable elements and radioactive elements. The lesser amount of binding energy for lighter and heavier nuclei explains nuclear fission and fusion respectively. Thank you.